All right, we will begin. I mean, say the thing is, we have a little more thing to say about the water pollutants. We will continue by that, but anyway, to start with this, let me make a correction here, that this one is not the toxic one. This one is toxic. The right. This one is toxic, and also in this part here I have not included two very important important heavy pollutant, a heavy metal pollutant, like this. One is mercury. One is essentially mercury, which is also a heavy metal contaminant, and also is another is lead. So the lead. So this mercury and lead, please include them. These two are important metals. These are two are very important heavy metals, which are toxic to many of them are known as toxic to human body or toxic to any other kind of organisms. Like, I will just explain you a case study here, or also similar to this is this, if you can see this. Okay. Now, what happens in such cases of mostly, in cases of heavy metals, many of the heavy metals are toxic, which has they are identified as identified toxins. These are identified toxins that they can relate to nephrotoxins, which are nephrotoxins is the nephron is the basically the kidney toxins. These are nephrotoxins generally known, and apart from that they are toxins which are generally find a good residence in gallbladders. These toxins, I mean, there are two. If we just observe the role of this toxin in the body physiological system, we just observe this two things like this. The toxins, heavy metal toxins get absorbed, right? Impair the release functions of hormones, then digestive juices, impair, say, this oxygen transfer, then CO2 release. The toxins gets absorbed. As they get absorbed, impair the release functions of the hormones, There is another impairment that takes place is, is, if you just see this, another impairment that essentially takes place here is this. If you can observe here, that they can be this say alters as right. alters the transfer mechanism, alters the transfer mechanism. Like, transfer mechanism is like this. It's a transfer mechanism is like this. Say if suppose just this is very illustrative, just try to understand this. If there is a bodily cell, if there is a cell like this, if there is a cell, we have there is the cell nucleus here, the cell nucleus, cell fluid, you just have the cell fluid. Now here the usual functions of the cell, is to release, say, carbon dioxide to the bloodstream. This is, say, where it is connected by connected to a bloodstream. Connected to a bloodstream. So this bloodstream, it is supposed to release carbon dioxide, right? It is supposed to release carbon dioxide, or it is supposed to release many other excreta that we generally gets discharged to the body, like, say, for urination, various digested products, right? And should carry on, say, should supply oxygen, nutrients, cell nutrients. This is what is it is normal function. What happens now if this water contains, if this blood contains heavy metal like, say, mostly the heavy metals like mercury, nickel, then cobalt, CO, nickel, cobalt, or sometimes chromium, then mostly this kind of substances. What they generally is this, they damage the transfer function. You understand this? By means of what happens is, the rate of discharge may be altered, rate of absorption, rate of discharge would be continuously altered. This would result in if these things continuously begin to take place, this would result in the permanent damage of the cell structure, right? The cells would naturally or regularly need oxygen, regularly need nutrients. Unless they get them, they would begin to dysfunction. This dysfunction might also, the presence of certain heavy metals which would be generally transferred by this process is called reverse osmotic pressure. Osmosis, this typical osmosis, the transfer takes place in an osmotic process, whereas liquid to liquid transfer taking place is basically that transfer phase is liquid to liquid or semi liquid to liquid kind of transfer taking place here. So what happens essentially is the transfer mechanism gets changed. As the transfer mechanism gets changed, the body would be accepting something which it does not want and would reject something which it would require. This is the alteration of this physical function that takes place in the presence of most of these toxins that we have been discussing. This is what is, one of them is the nephrotoxins, which is essentially impairs the kidney function. This is what is called nephrotoxins. There are another, this you must be already knowing about, say, you must be already knowing about the arsenic pollutants. Arsenic, is arsenic can initially the arsenic would be change the skin coloration. Persistence, this is, if it is short term, it will be changed, skin coloration would be changed. Persistence, if it is remaining, arsenic remaining in the water, arsenic remaining in water, say, would relate to say kidney function, kidney cell functions, say the kidney cell functions, then say metabolism, and can lead to all this kind of disorders can result into the change of the can result into the change of the cell structure itself if it is continuously taking place for a long time. This is what is called a cell mutation. The cell mutation is the initial step of formation of cancer. Cell mutation. When the cell is supposed to do a certain kind of job, its character has been so much changed that it is already doing something else. So this is the early onset of cancer. When this particularly spreads from one cell to different multitude of cells, this is essentially what is known as cancer. So all of them finally, all these dysfunctions, all these altered changes in the character would finally lead to cancer, or cancers would lead to cancers and can finally lead to fatality. They have itself this kidney and all this, when the effects are pronounced, that can itself lead to this fatality. Importantly, another important thing that is very important thing about this, many of these heavy metals are, another important thing about this, many of these heavy metals, some of the heavy metals are also known as micronutrients. They are useful. We need a little bit of cobalt. We would need a little bit of chromium also. But this again, this is when it, as I have said, this one thing that is what it says is that when they at a small quantity, they may be useful. At a larger quantity, at a larger concentration, they may be extremely harmful. And not only that, even in many of these heavy metals, may be toxic at a very low concentration, say about 0.1 to 0.01 to 0.001 milligram per liter. They are extremely toxic even at very small level, small concentration. They are extremely toxic at very small concentration. Well, I'll discuss more on this. It's on a particularly a case study that I will explain, that I will continue, that I will begin to. That is generally is about a particular case of. This is called particular case study that I'd like to discuss here. In one of this is that mercury in a gold mining. Use of mercury in gold mining. Use of mercury in gold mining is a very potential, highly potential topic for discussion. Nowadays, gold mining, the recovery of this gold, industrial processes where mercury used to be used for gold mining, extraction of gold, this process has now been changed. Somewhere there are processes, there are industrial processes. It's quite a serious topic of discussion as well, where nowadays mercury is no longer used, no longer required in big industrial plants where they extract gold. Non-mercury gold extraction processes are becoming more and more common. But in small practices and small uses, mercury still remains a very important substance which is generally used for extraction of gold. One of that such situation is is a typical case where you have seen in many cases in India also you have seen that there's poor people by the river side, they generally use pans for gold panning, for to collect nuggets of gold, that are generally done. But this is particularly true particularly very common in Brazilian Amazon streams, where after Brazilian Amazon streams, where this kind of mining is very common. This kind of mining is very common. What is done is, done generally is the methyl mercury is used. Methyl mercury is used for amalgamation of the gold particles. Methyl mercury for amalgamation of the gold particles are generally used, right? Now this methyl mercury, mostly about 5 to 10% is used of the concentration that is generally used for the purpose of amalgamation of the gold particles. Only 5 to 10% are used, which form a bonding with the gold particles. Rest of about 95 to 90% are generally discharged in the stream. Is discharged into the stream. Now this methyl mercury, if you just observe this methyl mercury now, this methyl mercury gets readily absorbed. This methyl mercury, when in water, gets readily absorbed. It gets readily absorbed into the fish by metabolic process or adsorption in the body. Now this absorption in the body, now as a result of which this methyl mercury, particularly the mercury, the element mercury, this element mercury is highly stable and non-reactive. But can impart heavy impairment, particularly in the nervous system, and it goes, say, from the food chain. Say this food chain, say gold mining. If you just observe this gold mining here, then going to the fish and water species, fish and water species would finally find way into this through the vegetation and other things to the livestock, or itself it can directly go to the human population, human population, and can go further up in the food chain, can go further up in the food chain. Now here this human population would be directly affected by the typical kind of mercury related poisoning. Mercury related poisoning. The mercury related poisoning are something like this. Initially the impacts are the impacts. If you observe the impacts, first of all it would be is severe contamination. The first and the foremost initial symptom is body tremor. If it is body tremor is the first initial symptom of mercury being absorbed, right. This would lead finally to the narrowing of the visual field. If the intake begins to continue, if the intakes begin to continue, what would observe is the eyeballs would begin to be reduced and the visibility would begin to impair. There is a field visibility, the visual field, the what you can see under open eyes, normal eyes, you would be constricted. You will not be able to see that much, right. This would finally lead to seizures. The body would begin to seizures. Have you seen the patients with seizures, particularly those who suffer from say severe nervous disorders? Generally they undergo seizures, uncontrolled motions of the different parts of the body, uncontrolled motions of the different parts of the body, which can finally lead to coma and death. Most of the pollutants that we have, most of the heavy metal pollutants that we have discussed can have a serious health related problems as explained. So you can understand the importance of heavy metals, particularly related to industries, particularly all kind of industries, say manufacturing industries, production industries, all discharge a huge amount of heavy metals. In many cases, just for many cases people escape, the industrial houses escape by saying that our discharge of water is of low TDS, low TSS, low turbidity, right, low iron. That may not be significant. More important than that is what kind of elements are being discharged. Say, as I have said, if you are discharging mercury, that mercury the concentration of mercury may not be visible in the TDS. Remember this, that may not be observable in the TDS concentration. But unless you do the TDS, unless you measure the concentration of mercury in the water itself, you would never know how much mercury you are actually discharging into the stream. If you say that we are discharging low TDS water, that is not sufficient. In many cases that is not sufficient. In many industries, like if you go to industries like mining, if you go to any chemical industries, they would simply say that we discharge low TDS water. We just treat water and we discharge and we reduce say particular pollutant like zinc, iron, or say other substances like less toxic substances like zinc, iron, aluminium, less toxic, relatively less toxic substances, and escape by saying so. But in most cases, when the water can have a source where there is a possibility of high concentration of arsenic, high concentration of mercury, high concentration of nickel, lead, all these can be extremely toxic at very low concentration. So what is important in such cases is to know the elemental concentration of all these heavy metals. In many industries, it is now important and now necessary to know the elemental concentration of these heavy metals. It is not merely sufficient to know about TSS, TDS or dissolved oxygen or parameters like that. Dissolved oxygens may be more, dissolved oxygen may be sufficient, but that is not sufficient for that is not good enough for drinking water purposes. Even a high arsenic water may contain oxygen which is sufficient for consumption, but not the water is still not potable, still not good for or fit for drinking, isn't it? So this is what is, we generally explain that by saying this is what is mostly the heavy metal pollutants that I have discussed, and also we go from here, to other aspects like where we deal with this pesticides. Another important thing about the pesticides. Now, let me explain a little bit about these pesticides, because you may not be much conversant with these pesticides. Pesticides, whenever we are talking about pesticides, mostly the things that generally come to our mind is the DDT that we know is essentially a very famously known pesticide. But before that, most of the pesticides are essentially say organochlorine, organochlorides, organophosphates, and organocarbonates, and they can be also other organometallics. Now, it has very important consequence. Pesticides are not only used nowadays for for agricultural purposes or food conservation purposes. Pesticides are being used in paints also nowadays. That sometimes that people say it's a termite proof board. What does it mean? How it can be termite proof? If it is a natural substance, a typical organic, say plant material, it cannot be termite proof, because the termite should still find it good for their good for eating, isn't it? So how it becomes termite proof? So it becomes only termite proof because you must be lacing that wood with huge quantity of pesticides. Only if you are laced it, if you are painting with organopesticides, that substance become termite proof. But there is a risk. The risk is that is not being told. When it is said the termite proof, the advertisers or the manufacturer would not say how it has become termite proof. What is the process they have made? Secondly, this is number one. Secondly, you might have saved yourself from the termite, but you have added another problem to your living, that is the pesticide itself. The children would use those substances, people would normally use those substances, so you are reducing one problem by inviting another, or you are eliminating one problem by inviting another. So this is where this is what is the implication. I will just briefly discuss about about one pesticide or one pesticides that is very famously known is that organochloride pesticide, that is DDT, which is nothing but diphenyl phenyl trinitrate, trichloroethane, trichloroethane. DDT is considered to be a wonder chemical. In fact, much of our agricultural revolution, that world can at least give some food to the majority of population of 6 billion people throughout the world, is because of one of the chemical, because of this is DDT. DDT is, though it's banned in some uses, but it's still very much used in very many of these poor countries, advanced developing countries. DDT is still being used because it is very cheap, and the manufacturing of DDT is also easy. So it's a less cost intensive material, but it is highly, DDT is also having a very important feature in terms of pollution. It has a very important feature in terms of pollution. One important thing is about DDT is that DDT, as I have said, DDT is a wonder chemical. Till about till about 1960s, DDT was considered to be the wonder chemical, at least savior of humankind, because if humankind used to grow in that number, there was a requirement of a substance like DDT. So unless as I have said, we wouldn't have got food enough to eat if there was no DDT. But DDT has, DDT is where one of the first instances where DDT was the reason where this environmental movement actually began. In 1966, there was one very important book or document that came about, is that the Silent Spring is by Rachel Carson. She was essentially a kind of marine biologist and a reporter as well. Carson is later known to be more as a reporter. She is considered to be one of the 100 most important figures of the last millennium, right? So Carson is considered to be that because Carson first found out the dangerous effects of DDT. What she observed was that in a particular river system of USA, I think mostly in the Hudson River system, there she found that there's the river pelicans that they generally flock that area. River pelicans that flock in that area, they could not breed their offsprings, because due to the high incidence of DDT in their metabolic system. By that time, DDT was being used in the agricultural farm fields, so that the excess DDT that was not absorbed in the farm fields were basically being trickled down by the water, and that water used to be consumed by these pelicans. So what happened is their eggs, the eggshells were becoming thinner. So when they were trying to incubate the eggs, the birds found, Carson herself found that due to the body weight of the birds, the eggs were being broken. Okay, the eggs were being broken. So Carson first observed that. She didn't know essentially that it is because of DDT. She further investigated and found that this is because of the DDT possibly, that this kind of situation is taking place. Well, that has started a revolution. The Carson is considered to be one of the revolutionaries in environmental science, or revolutionaries of environmentalism, the ideas, the start of environmentalism that we know of. So the Carson was one of the visionary of that kind, who actually modeled the movement of environmentalism in the world. So, it's you can see this now. This DDT is also another very important aspect of another important aspect of DDT is that DDT is not known to be a toxin, not known to be a toxin, or it is not known to be toxic, or not known to be toxic. There is no physical or internal changes due to the high incidence of DDT. Just to let you know, all of us have a good amount of DDT in our intestinal system now, because the foods that we have contains DDT, and this DDT gets accumulated in our body. So, but DDT we generally have, even the humans have, almost all humans have certain amount of DDT stored in their intestinal system. Okay. Now, but DDT has another very important thing is that DDT is bioaccumulative. DDT is bioaccumulative, like many pesticides are. They are bioaccumulative. This bioaccumulative means that it would continuously move in the food chain. If it is in the food pyramid, if you observe in the food pyramid, the DDT would continuously move. Say the first, just to observe the insects. Insects would have this. Insects, from the insects, the birds would have it. Birds of the larger bird preys. From the birds, finally it would go higher to say birds, or say even this is one stream. This is one stream. There will be another stream, like say there's vegetation, through the vegetation, some soil, from soil to say to the plant root, plants, to the plants, to the leaves, vegetables, leaves and vegetables, to humans. And so what has started, according to the mass, this what has started to be a very small concentration, say at about, say if it is say 0.001 milligram per liter at the insect level or the soil level, this would keep on accumulate. So you can see in the next level it would be say 0.005 milligram per liter. Then in the next level it would be 0.001, say 0.01 milligram per liter. Okay. Say the next phase it would maybe 0.03 milligram per liter. So finally when it is coming to human, it may be 0.06 milligram per liter. This is the concentration. This is called the bioaccumulative nature. It would continue to accumulate in the organic systems. It will continue to accumulate in the organic systems, and this is what is the bioaccumulative. DDT does not have DDT is not known to be as I have said, DDT is not known as a toxin, but DDT influences the metabolic function. Influences the metabolic function. It also influences this ossification of the body, ossification or the bone formation, ossification of the body, ossification of the body, though it would not be generally observable, observable. So, but you can see the direct effect of DDT or similar pesticides is that a reduction in body weight, early graying, of hair, early loss of eyesight, and also might influence temperament, that a person becomes suddenly angry, or the person becomes suddenly very hostile, might be related to a concentration of DDT or similar pesticides in the body. Understood? So, what I mean to say here is DDT, though it would not manifest, you cannot have a clear correlation between DDT, concentration of DDT and the incidence of a certain kind of behavior. But though not being a toxin which would be readily observable, the DDT can influence the bodily functions, the growth, the physical growth, the mental growth. All these features can be directly influenced by the pesticides of similar nature, DDT. So, as you can see, it might be one incidence that that the children today are becoming of lesser weight, the children becoming are frail nowadays, children and the youngsters having problems of related to the digestive disorders or early graying of hair might relate to the high incidence of DDT in our food system. Okay. Another important thing that is we'll just bring in the discussion is that volatile organic compounds. Volatile organic compounds. This is known as the VOCs. We will know them as VOCs, volatile organic compounds. There are many volatile organic compounds, but just to name few is this tetrachloroethylene. Say this volatile compound, most toxic of this, there are the typical type of them is I'll explain you. The types are the vinyl chloride, tetrachloroethylene, trichloroethylene, one, 2 dichloroethane, what is their specialty? Specialty is they are volatile in STP, standard temperature pressure. That is why they derive a name of volatile organic compounds. They are essentially organic in nature, but as you can see they may have say this they may have the halides in them, they may have say different types of chlorinated substances, they might have any other substances, organics, they might also have some organics in some cases. So this can be they can have certain metallics also in that. So the speciality is that they are volatile in standard temperature pressure, that is very important. What are those? Cleaning agents, many cleaning agents are basically these volatile organic compounds. There is perfumes, sprays, and they are and many of them are known as carcinogens. Many of them are known as carcinogens or mutagens. Carcinogens or mutagens. Carcinogens or mutagens. What is this mutagens all about? The mutagens are, these mutagens may be not leading to a carcinogen, but not generally leading to carcinoma or cancer, but they can also have local changes, local abruptive changes it can take place, local abruptive changes they can take place. So usual phenomena, particularly of this, apart from being carcinogens themselves, they cause nausea, this is the vomiting tendencies, this is nausea, the vomiting tendency. So then metabolic disorder, if it is consistent nausea or consistent say unrest, metabolic disorder, and this can only be fatal also. In most cases it is, if it is persistent, all these disorders, if these disorders are, if there somebody is having serious metabolic disorders, this can be fatal at one point of time. Apart from that, they are very great use, they are almost used in various sectors of the industries. All these fumigants that you know of are this, then there's fumigants, then domestic repellents, then they are cleaners, as you know, domestic cleaners. All this can result in this. Whenever you are smelling something, you must be knowing it must be a VOC. In most cases, other than say camphors or things like that, in most cases it is a volatile organic compound. So whenever you are seeing a cleaner or any kind of agent where you can smell, you may be sure that there is some volatile organic compound. I will just tell you, a simple case where if you go to say this petrol pumps next time, just go to the petrol pumps, many of you go regularly, you would see that most of these people, most of those fuel fillers or those who use as the typical helpers in those in the service stations, they would complain of vomiting tendency. They would generally complain of vomiting tendency, and also you would see in many cases, unless that place is very well protected, very well ventilated, in such cases you will see that they always complain of some vomiting tendency, then turning of heads, then migraine, then pain in the brain, pain in the forehead, things like that. And usually you will find they take up, they handle this thing by using, say, pan, this particularly like Pan-Parax kind of substances, chewables, which essentially help them to get out of this vomiting tendency and dizziness, nauseatic tendencies, things like that. So here they are the people who are likely to be affected and are mostly likely to be affected. If the condition is not good, you will find their working life in that particular area is very low, very little. A person may be working there for 10 years, 15 years, but that is what they can sustain. After that he has to go out, and mostly he would suffer. Mostly he would suffer because largely because they are poor people, so they are likely to suffer also. And mostly in a society like ours, where there is no kind of social protection or things like that, most of these people are finally end up dying unattended. So these are typical features, typical aspects of this pollutants that we discussed. We will continue with the discussion of water pollutant modeling in the next class. Let me see, I have asked for them for the class. If it is available to us, we will get into that. With this, we end the today's class. Thank you.